Welcome to the 7th lecture on the NPTEL course titled Risk and Reliability of Offshore Structures. We are now discussing on lectures about module 1 on course Risk and Reliability of Offshore Structures. We will today discuss about the 7th lecture, where I will extend the plausible reasoning to derive some quantitative rules. In the last lecture, we said that if you know the information about two events A and B, until you know the information about the complete set of propositions, it is very difficult to conclude that what would be the confidence level on occurrence of event A, though you know that event B is sure to occur. It may lead to serious errors if you do not look into the complete set of propositions, which can add information qualitatively and quantitatively to develop or increase the level of confidence both on the event A as well as event B. We can also define the rest of the one. Following may be further defined. One, you can say the logical product, which is AB, which is called as conjunction, logical sum, which is A plus B, which is called as disjunction, the third one is what we call implication, that is A implies B. The fourth one is what we call as negation, which is A bar. Now, by combining these operations in every possible manner, one can generate set of propositions. Now, by combining these operators in different possible manner or ways, one can develop set of propositions say, for example, C could be one such proposition which can be generated as A plus B negation, A negation plus A B negation plus A B A plus B. You can see all possible combinations of conjunction, disjunction, negation and implication are combined in different manner to especially develop a set of proposition C, as you see in this equation 1. Now, the above combination of these rules lead to a question or lead to a set of questions. The above combination leads to different set of questions. Let us say what are these questions to be answered. 1. How large is a class of new proposition? Is it finite? The next question comes, does it require connectivity? And the last question comes, what is the smallest set of operation in the given equation? Now, let us say C is function of two events, let us say A and B, and C can take any value, either true or false as its value. Then the following composition is very interesting. Let us say the composition of A, let us say true or false. Let us have a small table and see what are the possible compositions. Let us say F1 of A, let us say F2 of A, F3 of A and F4 of A. Let us see possible combinations, because they can take either the Boolean value true or false. So, one can say this is true, this is also true. So, let us say this is true, but this is false. Let us say this is false, this is true, this is false, this is false. These are the possible values a function can take, as you see here. But one can easily combine them in a simpler manner. Combining them, one can also write as follows. Let us say, for example, true and true, therefore, F1 of A is as same as A, F2 of A, because it has two values, true and false. So, A plus negation of A, F3 of A, it takes false and true. So, one can simply say it is negation of A, and F4 of A can be simply A negation. On the other hand, let us say this is F4 of A, this is F3 of A. So, the above simple combination derives two basic qualitative rules as follows. So, two basic qualitative rules can be inferred from the above discussion. 1. We can easily say that the degree of plausibility is going to be represented by real numbers . 2. Correspondence to common sense shall be established. So that the plausible reasoning will closely lead to rules of thinking, as similar to that of human brain. Now, let us consider an example to understand this. Let us take an example. Based on the prior information C, let us evaluate A. Based on, let us say, prior information on C, let us say I am going to evaluate A. Now, add more knowledge to C. Then A becomes more plausible. This can be now mathematically written as A given C information is let us say A given C prime. Equation number 2. Also, B given AC can be said as B given AC prime. It means B does not change. Then AB given C dash is much greater than AB given C. There is a small change in equation 2. This should be C dash, this should be C. More knowledge is added to C, let us call that as C dash. Now, plausibility of A is much more than the prior information, therefore, this is the value. Therefore, equation 4 holds good even though B does not change any meaning related to A. Therefore, different ways of reasoning yield the same result, and hence it is always better to use all information to arrive at the correct proposition or correct knowledge level or conclusion. Therefore, two quantitative rules are proposed in plausible reasoning. They are very useful. One is what we call as product rule, other is what is called as a sum rule. Let us see one by one in detail. Let us say AB given C means that both A and B are true for given C. For given C. Now, the product rule states that if W is a function of AB given C, then one can say the function of B given C product of function A given BC. Call C equation number 5, where W is a monotonous continuous function for which the derivatives exist. Now, based upon the equation 5, let us extend the further discussion. For A is certain, that is, it is true, then A given C is same as A given BC, equation number 6. A B given C can be expressed as same as that of B given C. In that case, then W of A B given C is going to be W of B given C, W of A given B C, which is as same as W of B given C. Also, W of A given B C is same as W of A given C, which means 1. Let us talk about the sum rule. A given C is again a function of A negation given C, let us say, equation 10. Therefore, Wm of A plus Wm of A negation should be 1, equation number 11. That is, Wm of A B given C plus Wm of A given B C into Wm of B given C should be 1, equation 12. Let Wm be called as a probability then we can rewrite the above equation as probability of A B given C is Wm of A given B C product of Wm of B given C. Also, probability of A given C plus probability of A negation given C should be equal to 1. Therefore, probability of A plus B given C can be said as 1 minus probability of A negation B negation given C, which is as same as probability of A given C plus probability of B given C minus probability of A B given C. We call C question number 15. If A and B are mutually exclusive, then probability of A B given C will be 0. If A and B events are mutually exclusive and exhaustive, then probability of summation of A I given C should be sum of probability of A I given C which is equal to 1. Equation number 17. Equation number 17 indicates the total probability theorem. Further, we can also say probability of A I given C can also be equal to 1 by n, because we already said it is 1. Please note that equation 18 does not decide the shape of the function p. Equation 18 does not decide the shape of the function p. Therefore, one can say probability, hence probability is a function of plausibility of proposition A. So, that is the link actually between probability and plausible reasoning. Interestingly, A has a definite set of propositions. Now, let us consider the policeman example again. Which we discussed in the last lecture. Let us use logical reasoning now for this. We know that A implies B is a statement what we derived from that example, which says that if A is true, B is also true. This results in a simple statement, probability of B given AC will be 1. Also, probability of P given AC is much more than probability of B given A alone, because C increases knowledge about the whole event. Now, in this particular example, C can be identified in this particular statement of equation 20. We know that the knowledge of C has added value to the whole proposition A and B. So, C can be seen as the experience of the policeman. So, this is how logical reasoning is brought into play to connect A and B, which are physical events. So, this will now lead to conclusion that this concludes that P or probability of A given B C is greater than probability of A given C. So, one can easily connect plausible reasoning and probability, that probability is nothing but a function of definite set of propositions A which has got different plausibility on A. So, it is easy to understand the logical connectivity between the events if I am able to establish the definite set of propositions what we have in terms of events A and B, provided the additional knowledge of the event C adds information on to event A and B mutually and respectively. Let us move further our discussion to quantitative rules. Let us talk about product rule. In case of product rule, one is interested to know the plausibility of A B given C to those of A given C and B given C. So, what is the plausibility of A B given C in comparison to A given C and B given C? That is the idea what we are interested in. So, I want to know if I have the information of A given C and B given C separately, what would be the plausibility of A B occurring together given C as the knowledge, because C anyway is adding information more to both the events A and B individually. Therefore, to process the decision on the event of joint occurrence of A B, this can be broken down to two parts. Decide that B is true for B given C. So, I decide, so to understand A B given C, let us break this into two parts, namely decide that B is true for B given C. Having accepted that B is true, decide A is true. Decide A is true for A given B C now, or equivalently decide A is true for A given C, then decide, accepting that statement, then decide B is true for B given A C, vice versa. Accept A is true for A given C, then decide B is true further for given A C. So, either way you can look at them. So, to understand the plausibility of the joint occurrence of the event A and B for the given knowledge C, where individual knowledge on the events A and B are added value through C, one can break this discussion into two parts and try to decide each one of them independently, then try to find out the more plausible reasoning on the occurrence of A B, provided the knowledge status C is adding value to both the events independently as A and B discussed here. So, formally we can write this as, so formally this can be expressed as A B given C is a function of, let us say, B given C. First you accept B for given C, then you accept and decide A given B C. I call this equation number, let us say 1, under the heading product rule of quantitative rules. Now, the rules of agreement implies that given any change in the prior information C such that B becomes more plausible, but A does not change. Okay. This can be expressed as, let us say, B given C double prime, a new knowledge on B is much more of course than B given C. We know the probability rules based on which you can write the statement. calling equation 2. Therefore, now A given B C is as far as similar to A given B C dash, because we already said that though C double prime is adding more knowledge to that of B alone, but it does not actually contribute much towards plausible occurrence of the event A. So, by simple observation one can state that AB becomes only more plausible and not lesser under the above condition, that is A given BC double prime is either equal to or much more plausible than A given BC. Now, introducing the real numbers instead of having the Boolean values of true and false for the events A and B, now we can say that if x is indicated as B given C and y is indicated as, okay, let us say x indicated as B given C and y indicated as A given B C, then the function f can be rewritten as the function f now becomes function of x and y in real terms. This results in f x y being a continuous and monotonic. This results in this function becoming continuous and monotonous increasing function of x and y. This function has to remain continuous to prevent a large increase in the plausibility of A B due to small increase of plausibility of A given C or B given C independently. This implies the following, that f1 of x y can be said as a partial derivative of the function with respect to x, and f2 of x y can be said as partial derivative of the function with respect to y. I call this equation number 5. Then f I actually denotes the differentiation of the function of the ith argument of the function f. For example, if one is interested, to know the plausibility of A B C given D, to know the plausibility of A B C given D, the three statements are simultaneously true because of the fact that Boolean algebra is associative. So, this can be now evaluated in two ways. One way is to consider B C as a single statement and proceed. So, A B C given D can be said as function of B C given D and A given B C D. This can also be said as function of C given D, B given C D and A given B C D. Let us change this bracket. Equation 6, equation 7. Alternatively, one can also say AB is considered a single statement. Instead of BC, consider AB as a single statement, then one can write ABC given D as function of C given D, AB given CD, because AB is a single event now, which can be now said as function of C given D, function of A given BCD and B given CD. Equation number 8, equation number 9. Therefore, one can extend the discussions of these two ways, considering either BC as a single statement in a given plausible reasoning of ABC given D, or AB as a single statement. One can summarize this as function of x, y and z can be now expressed as function of x with function of y and z. So, in this lecture we discussed about introduction to quantitative rules. We are discussing the derivation of product rule. We will also discuss the derivation of sum rule in the next lecture. We help you to connect the plausible reasoning with probability theory and try to understand how plausible reasoning can add knowledge value to probability theory. Thank you very much.